Okay, thank you Vansh for that problem. Now let us move on. Let's try to continue our trigonometry. Where is this? Okay. Just a second. Application not responding. What happened to it? Wait for some time. Okay, so before we go there, so in the last class we studied about the. Okay, is it visible now? Okay, very good. So in the last class we studied about some of the basic ratios by which we can divide a triangle. So now, firstly, before we jump right into it, I would want to give you some um, recap on what we did, because it was a quite complicated topic as compared to the usual mathematics that we usually do. So we are looking at different ratios of sides in a right angled triangle. So that's very important. We are studying about right angled triangles. So how are we studying the ratios? We are studying the sides based on some angle which we are calling as angle theta or angle x, whatever that is. So in this case it is this angle, and then we are saying that this side is the opposite side. Opposite is something, it's opposite, that is exactly opposite to the angle. Adjacent is something that is right next to the angle. So this side is the adjacent side, and the hypotenuse is the longest side in a right angle triangle. Okay, so I hope all of you are very familiar with the Pythagoras theorem. How many of you do not know what a Pythagoras theorem is? Do you guys know what a Pythagoras theorem is? Okay, very good. Now, if you do not know what a Pythagoras theorem is, just let me know. The Pythagoras theorem, spell it. Oh my God. Okay, very good. So it says that in any right angle triangle in the universe, you square this side and you square this side and you add them together, you will get this squared. So Vishwam, you're saying that AB squared plus BC squared is AC squared, which is fine, but let us state it in terms of our the new names that we have given to sides. Let us say that it is opposite squared plus um, adjacent squared is always the hypotenuse squared. Okay, let's state it that way, because it is this side which is the opposite, this side is the adjacent, so opposite squared plus the adjacent squared will be the hypotenuse squared. Always remember that. It's extremely important for something that we are going to try to prove very soon. But just to check if you are all very, quite comfortable with the Pythagoras theorem, can you tell me what is the opposite side if the hypotenuse is 13 centimeter and the adjacent side is 12 centimeter? So I want you to use the Pythagoras theorem and try to tell me what the opposite side is. You can type the answer if you get it. So remember that the opposite side squared plus the adjacent side squared gives you the hypotenuse side squared. Once 5 squared is not the answer. What is the length of the? Very good, it's 5 centimeters. So 5 squared is the square of the opposite side. So the opposite side will be 5 centimeters. Okay, so all of you are comfortable with it? Okay, stop. Now, you might remember that when we did the last problem where we did the sine 30, now I'll just delete this thing off because I don't want to confuse you guys. But you might remember that I told you if we have a triangle in which this angle is the same. Okay, so now this is a triangle, right? And in this triangle we have this angle as some angle. If you make another triangle in which this angle is still the same, then the what trigonometry tells us is that the ratios of all the sides, which means the sine, the cos, the tan, all these guys will be the same for that particular triangle, because all of these ratios are based upon the angle. Now, before you think that this is something hard and confusing, this is something which you already know, but I'm trying to tell it in a slightly more mathematical way. If two triangles are similar, then the ratios of all their sides are the same. That is the definition of being similar. So you can think of it as, if two triangles are similar, then if the hypotenuse was twice as big as one of the sides, then even in the other triangle, the hypotenuse will be twice as big as the side. It is like, uh, let us look at, no, that is not congruence. Congruence is different. Congruence means they have to be exactly the same. Similar means one could be bigger, one could be smaller, but the ratios has to be the same. So I'll tell you how it is. Let us say that two cricket grounds, two cricket grounds are similar to each other because both of them are circles. Now, one ground might be bigger than the other ground, but because both of them are circles, the ratio of their radius to their uh, circumference is going to be the same. So those two will look the same. So think of it like this. If there are two shapes that are similar, then you could stretch or compress them and make them look exactly the same. Think of it that way. Uh, because it's like, for example, the only difference is the size, but the ratio is the same. That's the meaning of similar. So if I draw a triangle in which the sides are 6, 8, and 10 instead of 3, 4, and 5, that triangle is going to be similar to this triangle which you have on your screen, because the ratios of the sides is the same. Its hypotenuse will be 2 times bigger, it will be 10. Its one side will be 2 times bigger, it will be 8. Its other side will be 2 times bigger, it will be 6. So as long as you keep the ratios of the sides same, the triangle will be similar, and vice versa. If the triangle is similar, then all the ratios of the sides will be the same. Why is it? Why is it? Because I told you that this angle has to be the same. So what happens when that angle is the same? We know that all the three angles in a triangle add up to 180 degrees. So this angle is right angle, that is fixed. So in any triangle, any right angle triangle that we are dealing with, that angle is going to be 90. We are saying that this angle is also the same because we are saying that we are constructing a triangle in which the theta is the same. Automatically this angle becomes the same, because if the total has to be 180, all the three of them have to be the same. So the moment all the angles are equal, then the sides ratio is also going to be equal, because if this angle is 60 degrees and in another triangle also it is 60 degrees, then the ratios of all the sides have to be the same, because you cannot have another triangle in which we have 90 degrees, 60 degree, and 30 degree, but the sides are in some weird shape. The shape will be exactly the same. It is just that it could be a bigger shape or a smaller shape, but it will be similar. So what happens if it is similar? The ratios of the sides will be the same. So in this case, if the sine was 3 by 5, which you guys had calculated, it will be opposite by hypotenuse 3 by 5. In the bigger triangle, it will be 6 by 10, because this will be 6, this will be 10. 6 by 10 is nothing but 3 by 5. So the sine will be the same. The cos will be 8 by 10. 8 by 10 is nothing but 4 by 5. So the cos also will be the same. Tan will be 6 by 8. Or if the triangle is even bigger, let's say the triangle has 300, 400, and 500. Now that triangle can work because 300 squared plus 400 squared will be 500 squared. So this is 90,000, this is 1,60,000, this is 2,50,000. So that triangle will be possible. It will be exactly like this triangle. It will be similar. It is just that it will be bigger. It won't be congruent. Congruent means that even the sides have to be the same. That is when they are congruent, but they'll be similar. So in this triangle, we will have the sine ratio as 300 by 500, which is again 3 by 5. So what I'm trying to say is the sine ratios remain the same based on the angle. So suppose this angle was 40 degrees. We've calculated its sine value. That value will be the same for any 40 degrees in any right angle triangle. Sine of 40 degrees remains the same, because if you pick another right angle triangle in which there is 40 degrees, you're automatically saying that both those triangles are similar, because there is 90 degrees, there is 40 degrees, and the other angle is 50 degrees. So if those two triangles are similar, their sides will have the same ratio. If the sides are the same ratio, these ratios will also be the same. That is why the sine is the same for any triangle if their angles are the same. So sine of 30, this is something very important. Remember this. I'm not going to teach you all the sine values. I'm not, I don't want you to remember everything, because there is sine 30, sine 45, sine 60, sine 90, all of that. We can do that some other time. But just remember that sine 30 is half. That is what we had calculated in our last class, which means if you draw a triangle in which your theta is 30 degrees, then automatically your ratio of the opposite side to the hypotenuse will be half. Always remember that. In any triangle, if your angle is 30 degrees, okay, let me look at the doubt. Sir, does it mean that in any ratio or multiple of these numbers, when constructing a right angle triangle, will it stay the same? Yes, exactly. If you pick a right angle triangle, all the right angle triangles in which their sides are multiples of each other, which means, let's say you pick a right angle triangle in which it is 9, 12, and 15, it will be the same triangle. It is just that it is bigger. The ratio will be the same. Everything will be the same because all the sides are multiplied by the same number. If you multiply this side by 10 and this side by 5, that will not be similar, because then you are changing the ratio. If the ratio has to be the same, all the sides have to be multiplied by the same number. They have to be equally larger. You cannot just increase the size of the opposite side or the adjacent side. You have to also increase the hypotenuse. It's like you are enlarging the picture, or you're compressing the picture, but the picture should remain the same. It will be a similar picture. You're not allowed to shrink it where it is vertically pulled on, horizontally pushed. No. Okay, yes, Parv, what's your question? Let's do one thing. If you have any questions, just turn on your mic and talk, because in this class a lot of discussion has to happen. It's a slightly discussion type topic, so just turn on your mic and talk if you have a doubt. Sure, just turn on your mic and talk. Parv. Yes. Hello. Yes. What happened? I'm not able to hear you. Okay. Anyway, sir, when we enter a number in a calculator and find its sign, when we enter 100 and find sign, it comes, but how is even sine 100 possible? Okay, that's a good question. So that is, let's see what we get. So the thing about all these ratios and all of this is we are learning it in the form of a right angle triangle, but it doesn't necessarily mean that this is restricted only to a right angle triangle. There is something called a unit circle. There is something called a sine ratio. There's a sine wave. There's a graph, and there is something extra to this than just studying it to right angle triangles. But the easy way to understand it is to do it to right angle triangles. Let me put it that way. Okay. You can also have negative number signs and all of those things. So we'll worry about that some other time. But that's actually a good question. I'm glad that you went and explored it and entered it in a calculator and all of that. But to understand that concept, we will have to understand the unit circle, and that is, I think, a little complicated to understand at this point of time. So let us just keep it to simple um, triangle, uh, right angle triangle.
Sir,
Yes.
I didn't understand his question.
Okay. So his question was, there is, so he went into the calculator and he entered sine 100. Okay. Now he got some answer. Now he's asking, how is sine 100 possible? Because in a right angle triangle, this cannot be 100. So I told him that sine ratios are not only in right angle triangles. There's a different way of looking at it. There's something called a unit circle, and that is, we will focus on that. Maybe we'll not focus on that in my classes. You will learn it maybe in your PU classes. So I told him just to keep it simple and think about sine ratios less than 90 degrees, which can be represented through a triangle. Okay. Is there any formula to calculate sine? That's an interesting question. Um, in ancient India, there were some formulas, but I'm not sure if there is a simple formula. I'm not sure if there's a simple formula to calculate the sine of any given number. Let me just look it up actually. Let me look it up. I think that's a good question. Formula to calculate sine. Okay. So it's saying opposite by hypotenuse, but that is not what we want. Um, So there are some complicated formulas where you can get an approximation, okay? Uh, but there is no such, there's no simple formula like an equation where you can just enter a value and get exactly what the sine ratio is. These are things that are little more difficult to understand. But I think you can look up something like ancient Indian formula to calculate sine ratio, and you'll get something which might be interesting. You can try that. I do not know actually if that formula is to calculate sine or to calculate pi. I think there should be one for a sine ratio too. So just check it out. Anyway, so let us try to come back to what we were talking about. I want to prove to you something very exciting today, which is something really really cool. So there are three identities in trigonometry. There are three identities in trigonometry which are extremely useful and used everywhere, and you need it forever. The first identity says that sine squared plus cos squared is equal to 1. Okay, sine squared plus cos squared is equal to 1. This is a very uh, simple thing to remember, but a slightly complicated thing to prove at this level. But I want you to try to prove it on your own, after which I will teach you the proof. Can you guys please stop talking there about the proof that he got on Google? So just wait. So sine is opposite by hypotenuse, cos is adjacent by hypotenuse. I want you to try to prove that sine squared plus cos squared is 1 for any triangle, for any angle. Why is it 1? Can you try to prove why this is 1? So let me write down here. Sine is opposite by hypotenuse. Okay. Cos is adjacent by hypotenuse. Can you try to prove sine squared plus cos squared equals 1? I'm going to give you 5 minutes. Just try to think that these guys are fractions, try to square them, try to add them, and see if somehow you can get one. Did any of you get some sort of a proof? Tanmay, very good. Do you okay? Can you turn on your mic and talk and tell us how you got it?
Sir, I used sine and cos of the above triangle. Sine was 3 by 5 and cos was 4 by 5. So I squared 3 by 5 and 4 by 5.
Okay,
Like 3 by 5 and into 3 by 5 was
9
9
by
by
5.
9 by 25, and
Okay,
4 by 5 into 4 by 5 was 16 by 25. And
okay,
when you add 16 by 25 plus 9 by 25, the answer is 25 by 25.
very good. But we have to prove that it works in any triangle, not just in this triangle. When you prove something in mathematics, you cannot prove it using an example because that doesn't mean that it will always work out.
Yes, sir.
But it's a very good thing that you did, and I think that that's very good that you understood the concept and you tried to do it that way. Because if we are proving it using this triangle, then I could tell you that sine plus cos is 7 by 5, because 3 by 4 plus 4 by 5, 3 by 5 plus 4 by 5 is 7 by 5. But that doesn't mean that in any triangle sine plus cos will be 7 by 5. You could have a different triangle in which it will be different. But I'm telling you that sine squared plus cos squared will be 1 in any triangle. Okay, it is good that you tried it in this triangle. So we know that in this particular triangle, sine squared plus cos squared is 1. But can you somehow try to prove it in such a way that it works in any triangle? And let me tell you this, you can even prove it for a triangle where you don't even know the sides. You don't know its sides at all. You just know that it's a right angle triangle. You can prove that sine squared plus cos squared is 1. Anybody else got the proof, or anybody else think that they are in the direction of getting the proof? Okay, Vansh Patel says this is because the ratio in every triangle, if one angle equal, is same. Very good point. Okay, so now you have gone one more level better, because Vansh and Tanmay, if we combine what you both said, Tanmay said that in this triangle it worked. Vansh is saying that it will work in any triangle because if the angle is same, the ratio will be the same. Yes, so it will work in a triangle if this angle is the same. But what if I give you a right angle triangle in which this angle is not the same? Then you cannot use this example.
In every triangle, 90 in every right angle triangle, 90 degrees same, so it will work in each and every triangle.
90 degrees is the same, but what about these other two angles? You don't know about them. If one of those angles is the same, then you can say, but we don't know if the angles will be the same. And this sine 3 by 5 and 4 by 5 is derived from this particular triangle. So we cannot say that it will work in any triangle. Parv, that's a good strategy, but remember that you have to square it, not just add it. This is sine squared plus cos squared is 1, not sine plus cos. Sine plus cos is not 1. Sine squared plus cos squared is 1. Anybody else? I'm actually very much impressed with the way you guys are thinking. Okay, Aryan is saying, sir, I think hypotenuse is the same and adjacent and opposite are equal. Adjacent and opposite are equal, hypotenuse. No. I want a complete answer. Let me give you a clue. The proof to sine squared plus cos squared equals 1 involves this thing. Okay? It involves it somewhere. That's my clue. Tanvi, you have anything to say? You are typing something. Or Vishwam. Who else? Who is? Most of you have typed in something or the other. Vishwam and Tanvi have not. So I'm asking if they have something to share. Let us first just write down what we have to prove. We have to prove that sine squared plus cos squared is 1. So let us write it like this. Opposite by hypotenuse squared, because this is sine, plus adjacent plus hypotenuse squared, because this is cos, and we want this to be equal to 1. Is everybody agreeing with me so far? Does this make... Yes. Can you think now what should be done next?
Sir,
Yes.
sir, in particularly this triangle, if we use Pythagoras theorem, so the opposite side will be 3 by 5 and the adjacent side will be 4 by 5. And if we use this, the Pythagoras theorem will prove that the triangle sine squared plus cos squared equals to 1.
Correct, but you are doing it in this triangle. I don't want you to look at this triangle, because just because it works in this triangle, that doesn't mean that it will work in every triangle. That's what I'm trying to say. The thing about proofs, and I am myself suffering from this at this point of time in my own research work, is that it is not enough if you show that it works for something. You have to show that it will work in any case, no matter what. So when we discover something, we cannot say that it works in this situation, so it should work everywhere. No. We have to show that it will work everywhere. For example, when Apple made the first phone, suppose they had proved that this phone can be charged and it will work for 5 hours and you can use it for calling and taking pictures. Would anybody buy it? No. People would only buy it if they said that any phone that is this phone, if you buy it, it will still have the same properties. So the phone which he shows when he's launching the, during the launch of the iPhone, that phone, it's not enough if only that phone works, right? It should work in all the phones that they manufacture. So they have to come up with a strategy in which in any phone, in India, in England, even if you take the phone underwater nowadays, it should always work. So when you prove something, you should prove it for all cases. Okay. So,
Sir, can you give where my property does not work?
yes, can you repeat your question?
Sir, can you give me a case where my what I said does not work?
No, because this theorem is actually true. It will work in every triangle. In any triangle, if you take sine and cos, it will work. But we have to show why it will work. And to show why it will work, we cannot use any example. Because when you are using an example, you are assuming that it will work for that example. But that doesn't tell you that it should work for any example. And if you tell, can you give me a case in which it doesn't work? That might not be enough to say that it works, because we might not be able to give a case where it does not work. But still, that doesn't mean that it will work for everything. Just because we cannot come up with a counter example, it does not necessarily mean that there is no counter example. Now, for example, you might not be able to find a dog that has 5 legs at all, but that doesn't mean that it is impossible to have a dog with 5 legs. It might still be possible. So you have to prove that a dog with 5 legs cannot happen using some scientific thing you have to prove. Then you can say, you cannot say find me a dog that looks like that has 5 legs. Okay, Tanma is asking, sir, is opposite plus adjacent equal to hypotenuse? No, it's not. Can you remember what the Pythagoras theorem is? Is opposite plus adjacent equal to hypotenuse? Or is opposite squared plus adjacent squared equals hypotenuse squared? Yes, that is what the Pythagoras theorem says. The Pythagoras theorem says that if you square the opposite side and if you add it to the square of the adjacent side, you will get the square of the hypotenuse. It doesn't say that just, can you check, does opposite plus adjacent in the triangle, does 3 plus 4 equal to 5? No, right? Opposite plus adjacent is not hypotenuse. Opposite squared plus adjacent squared is hypotenuse squared. Okay, so now let's solve. First thing what we will do is we will open the bracket. So when we open the bracket, what happens? This becomes opposite squared by hypotenuse squared plus adjacent squared by hypotenuse squared equals 1. Do you guys agree with this? So if you have a fraction which is like 1 by 8, and if you want to square it, it becomes 1 squared by 8 squared. Do you know that the square goes to both the numerator and the denominator? Is this making sense so far? Do you guys agree? If a fraction has to be squared, it should go to both the numerator and the denominator, right? Okay. Now, do you guys know how to add two fractions? When we add two fractions, we keep the denominator the same and we add their numerators. We have to do LCM, you're right, but in this case the denominator is the same. Both these fractions have hypotenuse squared as their denominator. It is like 4 by 5 plus 8 by 5 is 12 by 5. You just can add it because 5 is the common denominator. So here hypotenuse squared is a common denominator. We don't care what the number is, we just know that it is the same in both the cases. So this becomes opposite squared plus hypotenuse squared whole thing divided by, sorry, I put adjacent squared, I mean adjacent squared divided by hypotenuse squared. We just add these two fractions. This is one fraction, this is a by b, this is another fraction, c by b. If a by b plus c by b, if you want to add, b is the denominator, it remains the same. So this is our denominator. Numerators are being added, opposite squared and adjacent squared are the numerators. This should be 1. What is opposite squared plus adjacent squared according to Pythagoras theorem? Can you tell me what is opposite squared plus adjacent squared according to Pythagoras theorem? In any triangle, what is the opposite squared plus the adjacent squared? What do you get? Hypotenuse squared. Very good. So this becomes hypotenuse squared divided by hypotenuse squared, which is 1 because this is the same number divided by itself. Now we don't care whether this is 34 by 34 or 99 by 99 or by, okay, sorry, right? It's same thing, so it is 1. So without using any example, we have proved that sine squared plus cos squared is 1. Yeah, it's not that complicated, it's simple. It is just adding two fractions, looking at the numerator and realizing that the numerators add up to form hypotenuse squared, and it's the same thing in the denominator, so you can just cancel them out. Okay, so this is the proof. So always remember, sine squared plus cos squared equals 1 for any angle in any triangle. It could be 30 degrees, it could be 60 degrees, it could be anything, because the definition of sine is opposite by hypotenuse and the definition of cos is adjacent by hypotenuse. We can square those two and get 1. Yes, tell me. Yes, your microphone is on. Somebody's microphone is on. I'm not hearing.
Sir,
Yes. Tell me.
an example form.
You want an example?
Sir, no question.
Okay, tell me.
Sir, you can give us a question.
I have to give you a question. Okay. So let's see. Just if you want to verify sine squared plus cos squared, a triangle has hypotenuse 15, opposite side 12. Verify that. Verify the theorem. Can you verify this theorem? If this, so try to draw the triangle. First of all, see, wherever there's a problem in trigonometry, better to draw a problem. So just draw the problem, draw the triangle, put the hypotenuse as 15, pick your theta, whichever is your theta, put that the opposite side is 12. Now check if sine squared plus cos squared is equal to 1. This is your homework problem, okay? This is your homework problem. Verify the theorem. No, 9 is the side. The 9 is the adjacent side, yeah, but I want you to prove that sine squared plus cos squared is 1 for this particular problem, okay? Try to prove it for that particular problem. So you can find out what is the adjacent side, and then you can do the sine, then you can do the cos, then you can add them together and see if they do add up to 1. Okay, Parv's question is, can you prove that the sum of any three consecutive numbers is always divisible by 3? Yes, I can prove it.
Sir, can I prove it?
In the next class. We will do that in the next class. Okay? Okay. Prove. Okay. So your question was, can you prove it? I just said, yes, I can prove it. So I'll prove it. Wait. Listen. Yeah, tell me.
Sir,
What?
so yeah, we can do like that. No, x plus x comma x plus 1 plus comma x plus 2 equals to that we have to prove this equals to 3. So if we divide it by 3, we can get 3. 1 like that.
Done. Proved. I haven't explained much about what I did there, but you can look at it and try to understand what I did. So, uh, anyway, let's stop for today. I'll stop recording. You can still ask me the if you want to talk anything in general, but I'll stop recording just a second.